Welcome to Maths for You YouTube channel. Past question on mechanics. Question number 1. The position vector of vector r meters of a particle at time t second is given by vector r equal 1 plus 12t minus 2t squared I plus t squared minus 6t j. So this displacement vector is given. It's r. So the function is in t, variable t. Find the expression for the velocity of the particle at time t. So simply the displacement vector is given. To find the velocity, just differentiate. Differentiate will give us the velocity. So the differentiation of displacement will give us the velocity. So the Vt equal dr over dt, and so the first part I coefficient differentiation is 12 minus 2 times 2t, because 1 is 0, 12t is 12, minus 2t squared, 2 times 2t I. And then j, coefficient of j is t squared, differentiation of t squared, 2t, minus 6t is differentiation of 6t is 6. So if you could simplify, Vt equal 12 minus 4t I plus 2t minus 6j. Further simplification, take 4 out of the first part, the coefficient of I. It's inside 3 minus t, inside the bracket 3 minus t I, plus 2 out of the bracket common, t minus 3 j. So that is V, the velocity of the particle with the position vector. The displacement vector is 1 plus 12t minus 2t squared I plus t squared minus 6t j. Then said can the particle be, or would the particle be stationary? So in other words, the velocity has to be 0. So Vt equals 0 at a particular time. Of course, if it happens at a particular time, the coefficient of I and j must be 0. Then only the Vt equals 0. So when t equals 3, that satisfies that V equal 3. The I coefficient, I part is 0, as well as the j part. Therefore, V equals 0. So the particle will be at stationary when t equal 3. A simple question, done. Second question, it's slightly forces. This question with forces. The first question was velocity, and the second question is forces. So when we deal with forces, let's start with the question first. Rory pushes a box of mass 2.8 kilogram across a rough horizontal floor against a resistance of 19 Newton. Rory applies a constant horizontal force. The box accelerates from rest to 1.2 meter per second as it travels 1.8 meter. So in other words, so the box weight is 2.8 kilogram, the mass, and it's on a rough horizontal floor. Then Rory pushes, so therefore there must be a friction, flow friction, that is given. It's 19 Newton, and Rory is applying a force, and the particle or the box has started to travel or started to move from rest and reach the velocity 1.2 meter per second after 1.8 meter traveled. So calculate the acceleration of the box find the magnitude of the force at Rory applies. So let's put all in one. So I'll put a little sketch. So the floor is a rough horizontal floor, and the box is the weight is 2.8 kilogram, and of course the reject the the force from the floor, the vertical force from the floor is R, the flow reaction, and again the friction, the horizontal flow, the rough horizontal friction is given. Just notice as F equal 19N, and again Rory pushes from left to right. His force is P, and again it's travel 1.8 meter. So I just put S here. So it's just 1.8 meter, and the velocity after 1.8 meter is 1.2 meter per second is given. Acceleration we don't know. Throughout the travel, the acceleration start from the finish. I just made it as A meter per second squared. So the box pushed from the rest to 1.2 meter per second. The distance travel is 1.8 meter. And so simply we can use the Sweat equation, or Newton's equation, is V squared equal U squared plus 2AS, because we know the distance, we know the velocities, but we don't know the acceleration, which we need to find. So this is one of the three equations, V squared equal U squared plus 2AS. V squared is the final velocity, so 1.2 squared. Initially it starts from rest, therefore the velocity is 0, plus 2 times A times distance 1.8. So if you could bring that A to left hand side, the number to the other side, so 2 times 1.8, 3.6 A equal 1.2 squared is 1.44, and A equal 1.44 divided by 36 is simply 144 divided by 36 is 4 and 1 decimal place. So acceleration is 0.4 meter per second squared. That's one of the question. The next question, we need to find the force which Rory applies to move the box. So we have to use the Newton's second law equation, F equal ma, and just put a box along. There are 4 forces acts on that box. One is the vertically down is a mass, vertically upwards R is the reaction from the flow. We don't need to worry about that, those two, just those two are equal. So R equal 2.8 kilogram, just leave it, or 2.8 Newton. So if the forces we want, horizontal forces, so left to right horizontal force, the Rory pushes left to right is P, the friction is right to left is F equal 19, therefore the equation, if you apply F equal ma, so P minus F, P is the Rory's force, F is the friction, equal m is the mass, A is the acceleration. The P which we need to find, minus 19 is friction given, 19, equal mass is 2.8 kilogram times acceleration 0.4. From that we can just work out a calculator, using calculator. The P is 20.12 Newton. So the Rory's force, the constant force, is 20.12 Newton. Both are very basic, simple question. It's from Oxford and Cambridge paper. Thank you. Please subscribe the channel and share the contents with other students and friends. And most important information, please send some questions for me to make more videos. Thank you.